Okay, so section 3.1 is determinants. So a 2x2 determinant, we already talked about this. How do we find it? So if we have a matrix A, B, C, D, there's a few different notations that we can use. So we can say the determinant of A is, and what do we do? AD, no, not 1 over, it's just the AD minus BC. AD minus BC. We use 1 over determinant for part of the inverse, yeah. But the determinant itself is just that. So the other way we can write it, so if we have, let's say 1, 1, 2, 3, so we would say the determinant of A is 1 times 3 minus 1 times 2. All right. If I want to make an inverse really easy for you to solve, I make the determinant 1, then it won't have fractions in it, right? So the other way we can write the determinant is to actually put the determinant in front of the matrix like this. And then just put an equals. So this will be 3 times 2/3 minus 2 times minus 1. 4. Right? And then the other notation for determinant is like this. Like an absolute value. So look close in the book, sometimes they'll write that, and that just means determinant. So when it's this, instead of the square brackets, just straight brackets. So this would be 1 times 6 minus 2 times 3 is 0. And a determinant of 0 is okay, but what does it mean about the inverse? Right, no inverse. And while we're talking about dependent, always has a determinant equal to 0 as well. If it's a square matrices, independent, determinant not equal to 0. So that would be another way to tell without going through any row reduction. If you found the determinant and it was 0, then you could conclude it's dependent. But then if you were asked to write the linear combination, you still have to row reduce. But you don't have to row reduce to figure it out. You could just find whether that is 0 or not. Okay. All right. So a 3 by 3. And determinants are only for square matrices. So 3 by 3, 4 by 4, 5 by 5. So 3 by 3, I'm going to show you a method not in the book, but it's the way I do the determinant. Okay. So I'm going to color code this for you to see, and then there's longer ways, which is what we'll learn the next 2 techniques. Okay, so I'm going to call this method 1, which is not in the book. This will look like a great big long formula, but it's not as hard, and you don't need to remember all the letters, right? Up here, you don't, when we do a 2 by 2, you don't actually memorize the letters. You just know you go forward and then subtract going backwards. We're going to do the same thing, go forward, but when it's a 3 by 3, there's more ways to go forward, okay? So the first way to go forward is that way. A times E times I. Do you see it? The forward diagonal. Okay. Let's put a square bracket here. Plus, the next way to go forward, B, F, and G. So it always has to have 3 numbers. So 2 with the third. Okay. B, F times G. What do you think the other one is? you're right. So DH with C. DH with C. All right, so that's forward. Can you see this sort of the three diagonals that way? And then we subtract the similar three but going backwards. Okay, so add them together. I would add and then find that number, and subtract them, rather than trying to subtract each one and changing negatives. Sometimes you'll have 3 or 4 negatives, so it ends up being, it's better to add them. So what's the first one? C, E, G, so the backwards diagonal. And then what? Go here, B, D with I. And what would the last one be? Right here. F, H, and A. So do not remember the formula. Don't use it as a formula. And this is sort of a cheating way to do it. It doesn't work with any other. It's not practical with the 4x4, 5x5. It would be very complicated, okay? But with a 3x3, especially if some of these numbers are zeros, it's a quick way without having to row reduce or do anything special. Okay, so let's just do a couple examples of the determinant that way. And I'm going to write each number out so you can see how we got the multiplication, but then after that we don't need to write them all out. So what are the forward ones? 1 times 3 times 0. So that's 0. Normally I would just write it as 0. So that's the first one. The second one, 2 times 1 times negative 2, the one that's by itself, plus 0 times 5 times negative 1. So that's forward. Subtract, going backwards. Minus 2 times 3 times minus 1. Zero times 2 times 0. A 1 and a 5. So how I usually do it is just figure out each bracket. Minus 15. Okay, and we'll do that again later to see. I'm going to show you one of the other methods. Then we'll take a break and then do the longer method after. Okay, so Laplace expansion, so that means longer, expand, to find the determinant. So I do use Laplace expansion when there's lots of zeros in a matrix. Otherwise, I just go back to my method because I find it quicker. And then I use Laplace expansion myself if I want to find the determinant if it's bigger than 3 by 3. So 4 by 4, 5 by 5. We'll do it for a 3 by 3 to start, and then I'll show you with 4 by 4. So the determinant of a matrix is the dot product of any row or column and the corresponding row or column of cofactors. So we need to know what the cofactors are, but I'll show you. Okay? So that's what we need to know, what the cofactors are. So let's say we have A is okay, so here's the matrix. So what I'm saying to do is the dot product of any row or column here. So first of all, you pick a row or column. That's step one. So what you're looking for is some zeros, because that will eliminate some of the work. So there is 1 0 in here. So there's really a good row and a good column to pick, which would be row 1 would be okay because it has a 0 in it, and column 3 would be another choice that has a 0 in it. You can do Laplace along any row or column, but if it has a 0, that eliminates part of the work because it'll be 0 times something. So pick a row or column, the one with the most zeros. Okay, so that would be your first choice. And then step 2, write out the Laplace expansion, which I'll show you how to do. All right. So let's say we're going to do along row 1. Okay. So we take row 1, and we're going to dot it with the cofactor. So I'm just going to put C's in here. So what place is this one? What place is that in? Row 1, column 1? So I'm going to put C11. Okay. And this would be row 1, column 2, C12, and row 1, column 3, C13. Okay. So I need to find those 3 numbers, and then I do the dot product, and that will be the determinant. So there's 3 calculations to do. So what are those cofactors? So the cofactor, any cofactor, is minus 1 to the I plus j times mij. Now what the heck is mij? This is getting worse. So, and this looks complicated, but it's not. I'll show you. That's just whether it's a positive or a negative sign. Okay? So don't worry about the negative 1 to the I plus j just yet, because that's really easy. The mij is called the minor. The minor is the determinant of the matrix left if you cross off row I and column J. So, this is not actually very complicated. Writing the notes for it is. So I'm just going to put my A back down. Okay, so we're going along here. Okay, so the first one, this is in row 1, column 1. It's useful to maybe write these down. So C11 is negative 1 to the 1 plus 1. What's 1 plus 1? 2. So negative 1 squared? Just 1. So that's just telling you whether it's plus or minus. And then our minor, I'm going to put a straight line for determinant instead of writing DET. The determinant of the matrix found by crossing off that row and column. So if I cross off that row and column, I have 2, 1, 5, 2 left, and we know how to find the determinant of that. So this would be negative 1 squared, which is just 1, times 4 minus 5. So 1 times 4 minus 5 is negative 1. So C11 is negative 1. Okay, so let's do C12. So that's negative 1 to the 1 plus 2. So negative 1 cubed, which would be negative. And then our matrix found by crossing off that row, again, and this column. So we would have what? 3, 1, minus 1, 2. So find that. So negative 1 cubed, which is negative 1. 6 minus a minus 1. So negative 1 times 6 plus 1 is negative 7. Follow? So it's actually not hard, it just looked weird when I wrote out the instructions. C13 would be, you just have to make sure you're going along the right row. So C13 is negative 1 to the 1 plus 3, crossing off that row and column, 3, 2, minus 1, 5. 15 minus a minus 2 is 17. So the determinant of A was found by taking that row, 2 minus 1, 0, and dot it with the cofactors of that row. Minus 1, minus 7, 17. And the dot product is what? Multiply. 2 times minus 1 plus negative 1 times negative 7 plus 0 times 17. It's 5. Now we could do it my way and double check that that is actually 5. The other way is pick another row or another column and do the same thing. Now I did that one out long, but you don't actually need to do all of that. It's actually even easier than that. So I did that one out long. I found all the cofactors. Which cofactor did we not need to find? The 17, because that was a 0. It would be 0 times 17, so we actually didn't need to find that. So I'm going to do it again with a different matrix and show you how to not find them, okay? So, actually, let's do the same one, but along column 3, so that you can see we get the same answer. So, same matrix. I'll do Laplace along column 3. And hopefully we'll get a 5. Okay, so let me show you how I would write this out. I don't put the dot product, I just put it all together as one equation. Okay, so this is how it looks. So here, let's circle column 3. So we're going to do 0. That's the first one. Minus 1, what position is that in? minus 1 to the 1 plus 3. And write your matrix. But we don't need it because it's 0 times that. So you could write the matrix, which we'll just do for fun, 3, 2, minus 1, 5. All right, how did I find that matrix? Cross off that and that, what's left? All right, plus the next number, 1, times negative 1 to the, what spot's that in? 2 plus 3? You could just write 5. And we do need this one because it won't disappear. So if we cross that out, 2, negative 1, negative 1, 5. And then our last one is 2. And that's in the 3 plus 3 spot. And we cross that out. We get 2, negative 1, 3, 2. We don't need to do this one because that's times 0. And then we just do the rest. So here would be negative 1 to the 5, which is negative 1. 10 minus 1 plus 2, that's a positive 1. This one's a negative. And this gives me 4 minus a minus 3. Good. And 5 was what we got last time. So you can pick any row or column, but just if there's lots of zeros in it, or even 1 0, it eliminates part of it. Okay, so let's do a 4 by 4. Or 5 by 5, something bigger. So I'll put a few zeros in. So 4 by 4. I'll just say that again, only square matrices. So there's no such thing as a determinant of a different matrix. It's not square. 2 by 2, 3 by 3, 4 by 4. So what's step 1? Pick a row or column. So which row or column do we want? Column 2, because it has 2 zeros in it. Right? And what are the minors? How big are the minors going to be? When you cross off a row and a column, how many numbers are left? It's going to be a 3 by 3. So when you cross off a row and a column, you actually have to do the determinant of a 3 by 3 as the minor, which you could then use Laplace to expand that, or you could just use my quick method, which is what I do. So we're going to go here. So determinant of A equals. So what I do when I solve it, I'm just going to show you my notes earlier. It's just making sure the number wasn't too crazy, like 118 or something. One of the ones on the homework was 118. So I don't know if you can see this because it's just in pencil, but this is me doing it without showing you how, right? This is how I would solve a determinant. I've got a lot of missing things here, right, because I didn't need them. Do you see what I put beside the numbers? Plus, minus, plus, minus, plus. So I was just saying, that's the minus 1 to the spot that it's in. So I just said, okay, this one's minus, that one's going to be plus, that one's going to be... I actually just stick the minus sign either in it if it's negative, right off, instead of putting that minus 1 to the power. So, all right, so here, this first one is in row 1, column 2. So we have a 2 there, negative 1 to the 1 plus 2, and then our minor. Yeah, so we'll get that in a second. What would be the next one? 0, and then it doesn't matter what's there because it's a 0. The next one is 0 again, doesn't matter because these are gone. And the last one is negative 1. Negative 1 to the, this is row 4, 4 and 2. And then our minor. Okay, so let's write the minors down. So you don't need the ones with the 0. You just need that and that. Okay, so in this first one for 2, we cross those off. So 4, 2, 1, 5, 3, 1, 0, 2, negative 3. So this will be negative 2, because that's a negative 1, and then whatever that determinant is. And here, we'll have negative 1 to the 6 is positive 1. So negative times a positive is negative. And then what's our minor for that? So this is here. So 1, minus 1, 0, 4, 2, 1, 5, 3, 1. There. So we need to figure out those two calculations. So we could do Laplace along to find those, which is what they do in the book. So if you had a 6 by 6, you would write out your Laplace transform. Each minor would be a 5 by 5. Then you would pick a row or column in the 5 by 5, write out the Laplace transform. Each one is a 4 by 4, and you would just keep doing that. We're not going to. We're going to just do it by the forward and backwards, adding and subtracting. All right, so for this one, so I'm going to go my 3 numbers forward, subtract my 3 numbers backwards, times negative 2. Then I'm going to go minus 1, my 3 numbers forward, minus my 3 numbers backwards. And then I'll work out the inside of the brackets, and then put your numbers in. All right, so for this first one, what are my 3 numbers going forward? So 4, 3, 5, 2, and 1. And then 0, 2, and 1. So just 0. And then going backwards, 0, 2, 5, and negative 3. And I'm adding each of them in the bracket. And then the other one going backwards, 1, 2, and 4. So I'll work these out after. The second one, going forward, four, 3, and, oh, is that a 0? Okay. 0. And then 1, negative 1, and 5. All right. And then backwards, 0. 1, 1 and 3, and 4, negative 4, negative 1, and 1. Uh, 10 times 3, negative 30. If someone figures this out for me, that would be good. Three minus 4. Ah, different answer than I got in my, where did I make a mistake? You got the same as this? Yeah. Did anyone else? You got the same? Or you're just nodding? So, the method's there. I might have made a mistake because I did the other one quick. I was just trying to make sure that it wouldn't be some strange number, which 10 is not. Not saying you can't. In the book, they don't seem to care if you get a negative 142, right? They just, so have your calculator when you're trying the homework questions. I had to multiply almost all of them. So that's how you would do Laplace. There's one other method which we'll do after the break.